muscles get tired, and they enter fatigue. Now, there are two kinds of fatigue. There's a psychological fatigue, it's called central fatigue, and that's where your brain just tells it's painful, and your brain tells you should stop doing whatever you're doing, because if you keep doing it, you're going to damage your muscles, right? That's that in terms of endurance kind of things. That's the hitting the wall you may have heard about before. People hit the wall. That's when your brain is saying, okay, you've done enough. If you keep doing this, you're going to damage muscles. But you know that you can get past that psychological fatigue. You can get that, and then we get that what's called the runner's high, right, when you do that. It's your body's mechanism of saying, well, I've told you that you should stop doing what you're doing or you're going to damage muscles, but you're doing it anyhow, so you must have to do it, so let's make it easier to do. So the brain releases a lot of feel-good kind of neurotransmitters like endorphins and enkephalins. They terminate pain and things like that, and that's the runner's high, and you keep going. Okay. But then eventually, you fatigue physiologically. Okay. Part of it's due to a buildup of lactic acid. Part of it's due to ion imbalances that occur in the cells. Rarely is it due to running out of ATP. Okay? Sometimes it's depletion of glycogen. But there are multiple reasons we could get this fatigue. But the point is, we fatigue, and it doesn't matter. I keep telling it to contract, but it will fatigue. And failure is the point at which there's no more tension generated. Even though we're saying contract, 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 it fails. Now, this is what skeletal muscles do in response to those repeated stimulus. We're going to look at some of this in lab today. One of the things we're going to do is to try to take some forearm flexors and send them into fatigue and failure to see how long does it take to reach fatigue and failure. So basically what you're going to do is going to just be gripping as hard as you can for as long as you can on this thing called a dynamometer, and eventually that will weaken. Because your brain's saying contract, 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 right? But you'll see that your strength gets weaker, 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 weaker. And that's because we've sent it into this summation, we've sent it into tetany, and then we've sent it into fatigue and ultimately failure when you can no longer maintain a grip strength. And then it takes time, right, for your body to recover from that. Replenish glycogen, replenish oxygen, replenish ATP, pump ions back where they belong so that you can reset the whole muscle cells and start over. Now that's a property that's kind of unique to skeletal muscle. Smooth muscle doesn't fatigue. Cardiac muscle certainly doesn't fatigue. Right? Your heart doesn't stop beating. Well, it does eventually, but it can just keep going. How many beats per minute? Average at rest, let's say 70, right? And that's how many in an hour? I don't know. 420. 4,000. What's it? 4,200. It's Monday. I'm tired. 4,000 beats per hour.